Thank you again for coming. Let's get started. Testing and in production, mostly based on my experiences from LinkedIn, but also I did a lot of research for this presentation, so you'll get good content. We engineers, we like to move fast and be productive. I say that we need two things for that. One is confidence, that our changes don't break production. The other is frequent releases. Now, you can have one of those two. Let's say you can have confidence when there's a QA team that checks if your code works, right? This gives confidence. I remember many years ago, this is how we used to work. Now, this does not quite allow us to move fast. This is not productivity, right? The true productivity is when you do continuous deliver and ship to production frequently. Now, I do have a question to you. Do you think it's possible to have confidence and those frequent releases without some sort of strategy for testing in production? Do you have it? I claim that you can't. Although, it depends on the scale of your application and the complexity of the system. But most of the cases, you really need to have strategies for testing in production. And I will illustrate the ones that are the most important, most recommended, and most standard these days. This is the best definition of testing in production that I have found. It is from 2012 by Seth Elliott. Testing in production is a set of software testing methodologies that utilize real users, live environments, to leverage the diversity of production while mitigating risks to end users. Mitigating risks to end users. The last part is very important. Testing in production is not some kind of cowboy programming where, we don't write tests, so we have clients and users, they will test the application for us. It's not the case. All those strategies are to provide better quality to our users. And we mitigate that risk. It's not that we expose them to a lot of problems. Check out those links. I have a lot of links in my presentation. And it's the definition from 2012, so it's quite a while. People were doing testing in production, especially the top tech companies. And I found the earliest references dating back to 2011, where people were actually talking about it at conferences. And I have no doubt that some of that was happening even in the past. All of the software patterns and everything was invented in 80s, right? Today's everything is just rehashing the same stuff. So what is the trajectory for testing in production? So in the past, we did a lot of unit tests and integration tests. So I'm not talking about the medieval times when we didn't do any testing. Let's say 10 years from now, not too far away. And this is our local environment and isolated testing, where we did a lot of unit tests and integration tests. This is good, that worked. We also had staging environment. It was a pre-production environment where a QA team can do some tests. Maybe your clients can do some acceptance testing before the application goes to production. Testing in production was not a thing. Some companies did it, but it was far from standard, far from mainstream. People didn't talk about it at major conferences. That was the past. Today, we still do unit testing and integration testing, and we are getting better at this. We have better frameworks. We have Mockito now. There's a talk today from Marcin Zajączkowski about Spock versus JUnit 5. It's going to be a cool talk. We should go. So we have better framework. We know better how to write those tests. And what about staging environment? Now, we still have it. It still has purpose. At the same time, we strongly believe in continuous delivery. This is the industry standard. Companies are realizing that to be productive, we need to ship to production frequently. So continuous delivery and automation. And now we need to automate some of our tests that used to happen manually on our staging environment. But it's tricky, it's hard, because staging environment has this inherent problem that there are instabilities there. And tests against staging are also slow. We're talking about those end-to-end tests. We are also doing a lot of testing in production. So this is pretty standard these days, doing Canary releases, A/B testing, and feature toggles. This is something that I hope I don't have to pitch and sell, and you know that it's valuable. So what's the future? We will keep doing unit testing and integration testing. 10 years ago, I did unit test classes and test-driven development classes. A year ago, I did another class like that. And I suspect that 10 years from now, I will do it again. At the same time, I have that sincere hope that like new college graduates and computer scientists will know how to write testable code and unit tests when they graduate from the university. I hope it happens at some point, and it's for sure it's happening already. Let's leave the staging environment for a little bit. What about testing in production? We still do it. We also will be doing more resilience engineering. Something that is, how many of you do chaos engineering or resilience engineering? Some of you? Very few hands, if any. Okay. This will be a thing, like only our applications get more complicated and are more distributed. Like we go to microservices. So application that used to be fairly simple now is a distributed system. With those levels of complexity, we need resilience engineering, and I'll talk more about it later, to identify problems and to be able to prevent some site outages and production issues. But what do we do with staging environment, given that we want to push for continuous delivery? And with staging environment, we have these problems with stability, and those tests tend to be slow. So my prediction is that staging environment will dwindle this pattern. Instead of that, what we have to do is we need to, the value that was provided to us through that staging environment, we have to get it elsewhere. We have to squeeze as much as value from our unit tests and integration tests, those isolated tests, right? So we want to shift to the left side. We also want to shift to the right side. I need to check where's the right. Yeah, we need to shift to the right side over there. So do more testing in production. This way we can fill this gap. And this is what we are doing at LinkedIn, and I will give you an example from LinkedIn.com, from our flagship application, where staging environment is not used for normal development. LinkedIn contexts. We are about 3,000 engineers, and 300 of us work for developer infrastructure, tools for engineers. We call ourselves a foundation team, and our goal is to provide amazing, invisible tooling for engineers. Engineers don't see tools at all. They're just very productive, and they can ship great products to production frequently, and in a stable, efficient manner. LinkedIn is part of Microsoft. I couldn't help but smile a week ago when I learned that Microsoft acquired GitHub. I'm very into developer productivity and developer platforms. And we at LinkedIn, we use GitHub mainly for our open source. For internal code, we use something else. Microsoft also has this other very robust developer platform, Visual Studio Team Services. I'm curious, anyone uses VSTS by any chance? Oh, some of you, awesome. It's also used at LinkedIn in some context, and I envision more of that being in use. LinkedIn consists, all our software is in 10,000 code bases. 60% of that is active, where there are active commits. Others could be some test projects and some stuff that is not actively developed. To give you a glimpse of a scale, we do 100,000 Gradle builds per day, including CI and local builds. This is because Gradle is our primary automation vehicle to automate and implement continuous production pipelines for across all technology stacks. So we use Gradle also for technology stacks where you normally don't see Gradle, like JavaScript, for example. Although in those contexts, Gradle is like a thin layer, and it delegates to native tooling. Flagship application is LinkedIn.com. This is our biggest app in terms of complexity and amount of engineers that simultaneously work on the code. It is 4 main code bases with roughly 7 million lines of code. And the scale is pretty neat, 300 unique contributors across those 4 code bases and 1,000 changes per week that we are landing. And with that, we are shipping to production several times a day. To do that is a constant challenge. It's hard. It's hard, but you can make it. And then once you make it, life is beautiful. Our engineering culture, we strive for cohesive engineering culture. We would like to have one team, although we have separate code bases. We like when engineers have standard tools. And when you move from one team to another, you know how to work. You know how to get the code, how to submit code for review, how to push your code to production, because the tooling and the workflow is standardized. An example of that standardization is code review, which is mandatory. So at LinkedIn, you can't say, hey, we're awesome developers, we don't need code reviews, we don't do bugs, it's all good. There's no opt-out. There's an article about code review that I wrote, like, check it out. Code review gave us so much, like mandatory code review at our scale, amazing avenue to teach, to get higher level of craftsmanship across the board. What I really like about code reviews is that when you keep giving like great code reviews to fellow engineers, and great code reviews is not like rubber stamping, yeah, looks good, just ship it to production, but really like thoughtful code review, not nitpicking, but like really useful comments that help to get code better and help someone else to get better in engineering. This percolates, like other people do it then. Like you do great code reviews, other people do great code reviews, and it's like this nice network effect. We automate everything, so from commit to production, we want that pipeline to be completely automated. We continually work on this. A lot of projects already work in that mode at LinkedIn. What we want is when developer works on a change, like we want the process of taking that code change to production to be fully automated. And we're talking about automating also Canary releases, where like new version of the app is released on a small number of hosts, and if the signals are good, like it gets rolled out to the full deployment to all the hosts. Like we are talking about that level of automation. We want that to be completely automated. We do trunk-based development and continuous delivery. This is in essence our like engineering culture. On the high level, what is our testing strategy? So there's no test engineer role at LinkedIn. We used to have it a long time ago. Circa 2015-16, we completely phased out, and it works very well. Like I work with many engineers at LinkedIn, and some of them used to be QA engineers, testers. Now they are engineers, they write code, they write tests, they get stuff done, they are brilliant. Like it all really worked well for us, this transition. In LinkedIn.com, which is like our product that has a lot of developers and is very complicated, we have continuous delivery in 2015. It's important because some forms of continuous delivery at different levels and for smaller apps, for smaller microservices, it was present at LinkedIn like long before 2015. But like, I feel that only when we moved LinkedIn.com to continuous delivery, this is where we really embraced it, because this is where it pushed us really hard. Like the challenges that we saw and we had to tackle is like amazing. Like it's like a separate presentation only on that. And this is one of the great decisions that we made, to push hard for continuous delivery. Developers are responsible for testing at LinkedIn. There's no QA role, so developers are responsible. It was somewhat like a culture shock at some point, like in the past, where, wow, like my code goes to production in a couple of hours. So I really have to get the quality in now. I have to think about tests and whether it works and whether this is stable, whether it performs, all that stuff today now. I can't just do happy coding and like somebody else will test that in the future, or maybe I'll write a test tomorrow or a day after tomorrow. No, you have to build in, because code goes to production very frequently, and you're responsible for testing. We have long testing and production tradition, dating like even like way before 2015, way before we embraced continuous delivery in the form of Canary releases or A/B testing, which I like to associate that with staged feature rollout because it makes it easy to talk about it. One key concept here is that, and it's something between testing strategy and your continuous delivery strategy, is separation of code rollout from feature rollout. So traditionally, many years ago, like when you deployed a new version of your app in production, this means that users were seeing new features already, right? You have a new version. Like that's not the case when you separate code push from feature push. If you do that, what's happening is that, yes, you have deployed new version of your app to the production, but nobody sees any changes. Nobody sees new features. Only when you slowly ramp those features, you slowly expose larger portion of your population, of your users, to that new features, to those new behaviors. Very important. This is like our key mitigation strategy to allow us to that, and this is absolutely a testing and production strategy. All right, let's talk about staging environment, my favorite subject. I'm not going to complain that much, I promise. Some of the challenges that we observe with staging environment that we have at LinkedIn and we have had for many years, it was very useful for us in the past. Now we are seeing that it's really hard to keep it stable. I mean, how is your staging environment? Is it stable? Yeah? Do you find value? Is it useful? Or is it like, I don't want to use it? So I talked with some of you past few days at the conference. How are you doing your staging environments? I've heard some interesting stories. It works for some of you. Some of you say that it's dead. Nobody uses in my company staging environment anymore. The problem of stability of services is there as well. One of the conflicts that I want to indicate is that with staging environment, our pre-production environment, it's I want to test my changes. So my service is unstable, but I want everybody else to be stable, right? And everybody else wants the same. He wants his stuff unstable, everybody else is stable. And how can you reconcile that? It's hard. Also, it is really hard to replicate a complex distributed system in a way that you actually get value of it, right? You actually can find issues that you think you would find in production. It's not impossible, but it's hard. Also keep in mind that we're doing microservices now for 10 years. It's a default mode of operations. Even small or medium-sized applications now will have tens of microservices, which are separate apps, separate development cycles. So effectively, every small or medium-sized application today is becoming a distributed system, and distributed systems are complicated, right? So it's kind of hard to replicate production staging. You can try to make it work, and maybe it works for you, so it's good for you if you find value, but keep in mind that it's hard. And that if you keep that in mind, you can explore other ways of ensuring quality and building that confidence and enabling continuous delivery in your organization without reliance on staging environment. So for LinkedIn.com itself, that one of our products, it's generally not used. We don't use staging environment that much. What developers would do is, when I work locally, what I can do is the downstream calls that need to be taken to the API service or some microservices, they would go to production. And production is super stable, it works, it's always up. Also, you can do it because we do continuous delivery. If I develop a mobile application, I don't have to wait. If I'm dependent on some new endpoint, something that needs to be rolled out in an API, then I don't really have to wait for this because we ship to production so frequently, several times a day, that it's already there. That endpoint is already in production. I can do my local testing. And in general, streamlining local development is very important. This is key of developer productivity. I don't want developers to, in order for developers to locally work on code, I don't want them to spin databases and bunch of other services and all that complexity on their local to get job done, to work. I want that to be streamlined. Either mock it out and isolate that environment, or make it or do the downstream calls to production. And this has been very successful for us. That worked very well for us. And we still use staging environment in some cases, and we have a project in progress to figure out what to do with it. How do we get the value that we are getting from staging environment without the cost, without the problems, and instability, problems with data, all that stuff. Canary releases, very important part of our testing in production strategy, and hopefully yours. So this is a definition from Martin Fowler's Bilky. Everybody else calls wiki. Fowler calls his wiki Bilky. He can. So Canary release is a technique to reduce the risk of introducing new software version in production by slowly rolling out the change to a small subset of users before rolling out to the entire infrastructure. This is for the way we do it is typically we deploy application to one host. Like that's, you can on multiple hosts, but typically the new version goes to one host, and then we look at the metrics. If the metrics are good, this gets then propagated to all hosts. Fantastic mitigation strategy for finding out issues that you can't find really in your unit tests and like integration tests or in local development. The way we do it at LinkedIn, we have a long tradition. We've been doing that for a long time. There is a link to an article on LinkedIn engineering blog, dated 2015. Important thing about Canary releases is that this should not be your primary way to catch bugs, right? You have code review, craftsmanship, and unit testing, integration testing. You should be catching a lot of problems there. Like if you routinely depend on Canary to find issues and you have to roll back, something is wrong. Something is wrong. Like it's worth looking into it. One of the challenges with Canary releases is that there are a lot of signals from a Canary. Like we look at hardware metrics, like what's going on with CPU and memory. We look at like any exceptions or new exceptions. We look at even business metrics. Teams can develop their own metrics and signals that then are emitted from Canaries, and we're tracking them. Because we have so many signals, there's a likelihood that you have noise. There is likelihood that some of those signals will have statistical significance, and you don't know if, is it broken? Shall I release or not? So there is constant challenge. Our goal is like fully automated Canary releases for like every team at LinkedIn. However, like some of the teams, especially when the app is more complicated, and LinkedIn.com is one example, requires us to have some like portion of developers, like an on-call person or an SRE, to be like looking what's going on with the release. But that's okay. That's not really like a big problem for us because we still ship to production several times a day. So it doesn't block continuous delivery, but I want to highlight that there is a challenge there. A/B testing. This is the definition from a research paper that we sent. This is bucket testing, split testing, or controlled experiment, a standard way to evaluate user engagement or satisfaction from a new service, feature, or product. We use A/B testing for that purpose. So for evaluating whether the feature makes sense, it moves our business metrics. So A/B testing is where you have, it's effectively a conditional in your code, right? Where there are two code paths. And then when we roll it to production, what's happening is that we can select a cohort. We can select some population of our users to see one behavior, and the other population of users, the control group, would see the previous behavior. And then we can truly find out whether, are we moving the needle for business? Is that change valuable? This is extremely useful for us. Now, the important thing is that we use our A/B testing framework not only for experimentation and identifying the good changes, we also use it for mitigating, for risk mitigation, for basically for some of our software components, all the code changes are wrapped within the A/B testing framework with a feature toggle to avoid exposing the user in case there's some problem with a feature. Since we are talking about feature toggles, I like to talk about them very close to A/B testing because feature toggles have different goal. Martin Fowler defines it as making large-scale change to software system in a gradual way so that you can release the system regularly when the change is still in progress. So the use case for feature toggle is what do we do with changes that are in progress? We don't want to do branching. We don't want developers to be sitting in a branch and long-lived branches and developing for several days or weeks in a branch. That doesn't really scale, that doesn't work. We want trunk-based development. At the same time, how do you trunk-based development? Well, you hide your changes. You push your changes to production all the time, but users don't see those changes yet because the feature is not ready. Check out the branch by abstraction article. Check out feature toggle article from Martin Fowler's Bilky. I like this concept branch by abstraction. It's very powerful. It means that we don't want to do branches in Git where we have long-lived, Let's take it back. Like I do branches in Git all the time, so I have nothing against the branches. We don't want long-lived branches when there's like a lot of development. Like you know how painful it is. If you have a lot of branches and you have to continually develop across them and cherry picking and all that madness, it's a lot of overhead. Like we don't want to be there. Instead, for unfinished feature, for work in progress, branch by abstraction is the strategy. So hiding that behind a feature toggle. Like at LinkedIn, A/B testing and feature toggling, it's like the same framework. We use the same technology for that. So it's like almost like the same thing. So at LinkedIn A/B testing, for us it's important because it allows us to do data-driven decisions. That's very key. LinkedIn is like really data-driven. If you saw Jakub Kubrinski's presentation from yesterday about metrics-driven architecture, so he talked a lot about being data-driven and how important it is. Check out, it was a great talk. Also, we test like everything with this A/B testing framework, this style. It's, of course, when we look at the web or like things that are very close to the end user, we will be using a lot of A/B testing to check if the changes on the site make sense. But we also use it for backend, like a search algorithm, and even infrastructure upgrades. Then one example I want to tell you is that what really clinched it for me when it comes to A/B testing is when I saw how search and relevance developers at LinkedIn, how they use A/B testing to find out if they are improving search. So I'm writing software. I code. So for me, it's easy. Like I write some imperative code or declarative code, and I see changed behavior of the system. I see new feature. But when you're working with search, right, it's different. Like you make tweaks, you make changes, and you don't know if you improved the search. How can you know? Like with certain level of complexity, and for us, search is very important. It's really hard to know whether you have actually improved search. You only can know if you look at business metrics. So you have to roll out your change to production, right? And some population of your users will be searching with your code change, and then you can compare results. You can see, oh, with my change, we see more click-through, like more people click on the first result on the search, right? Which is a great indicator that your search has improved. If people search and there's a list of results and they click on the first result, it means that they found what they were looking for, right? So we look at business metrics, and there's not, like, when you optimize your search, at some point you get to the point that like you really have to test with production. You need to do some kind of A/B testing to find out if search is further improving. So that was very, for me, like mind-blowing when I first saw it at LinkedIn. And in general, for us, this is how we like innovate and change the products for our members. Like at LinkedIn, we call like LinkedIn users, like hopefully you all have a LinkedIn account. Of course, you want to be connected to the best career opportunities. So this is how we innovate. But it's not only for members. It's also for us developers, for engineers at LinkedIn, because this enables us to make good decisions. I know as an engineer when I work on a feature whether it moves the needle, whether it makes the business metric go up or make them sink. This is important. Like when you know it, it validates your work. It makes you feel productive. It makes us productive as an organization. There's a great article about A/B testing, and we have a lot of articles on that on our Eng blog. And there was also a research paper that we have published on the A/B testing concepts. More about A/B testing. We have a long tradition of that. And for us, it's not only risk mitigation. Like I came from this, like for me, like I want developer productivity. For that, I need confidence and frequent releases. So I look at A/B testing as a way to mitigate risk, right? So that I can ship features, ship to production frequently, and if something goes wrong, I don't have to roll back everything and like creating like a chaos, but I can all ramp down a specific feature that is like not behaving well. But let's not forget that A/B testing is very critical for us and in general for making data-driven decisions. It adds complexity, right? So we are adding some conditionals to the code. So it comes with a cost. Like doing A/B testing is a cost. We we at LinkedIn, we gladly pay it because otherwise we wouldn't be able to scale and build large system with that amount of engineers that work for that work on the LinkedIn.com code base. It also adds complexity to your tests because you have to test all the code paths, right? The A path and the B path. Moreover, you need a way to delete the stale code paths. Once you ramp the feature to everybody, like you have some stale code path that is no longer executed at all. So we have an automated way to detect those, to like open tickets, and like some people are responsible to be fixing those code paths. It's important because you don't want your code to rot, to your code to accumulate tech debt because of the feature toggles that are not cleaned up. Where we use A/B testing, in certain contexts, like testing search or top of the stack web or mobile, this is where we'll be using A/B testing like as a standard. Like this is expected. Like every engineer is expected to wrap his code with A/B testing. This is then enforced by code review and like the culture of the company. Like if you forget to do that, you'll have the code review issue open. Hey, you know, where's the A/B testing? What's going on there, right? Now, when we talk about bottom of the stack, like a Java library that is like at the bottom of the stack, like we won't be doing a lot of A/B testing there. But that's fine. This is not what we need here. And some of the stats from our platform, it's called Excellent. So we run, each experiment like gives us like more than 1,000 metrics. There are like hundreds of experiments running in parallel, and there are like tens of member attributes so that you can really fine tune what is the target group that should see that experiment. With that amount of metrics and that amount of experiments, like we encountered very interesting like use cases and problems. What if you have those, like how do you reconcile results if you have so many experiments running in parallel, right? Because they can collide. You might be getting some weird changes on some metrics with statistical significance, but it's really because there's some other experiment. So we have, long story short, we have figured it out. And we found various creative ways to mitigate those problems. And like structure, like the population and those cohorts to like avoid those experiments overlapping. We also, like with that amount of metrics, you have problems that like so many metrics are changing that you kind of don't know, like, am I improving things? Let me use my example from search. Let's say the click-through on the first result goes up by 5%, but the click-through on the second and the third result goes down by 10%. Like, so am I improving the search results or not? Like, it's kind of hard to say. That's why we found ways and various rules of thumb that helps us like figure out what to do, how to interpret the results from doing A/B testing. Let's talk about LinkedIn.com, the architecture. I want to zoom into some of like how we do testing there. LinkedIn.com is 4 main code bases. So we've got web and our mobile clients. They all talk to one like API service, which then delegates to like a bunch of microservices. And API is supposed to be like a thin layer that only like aggregates results from microservices and backends and sends the content in a way that the clients can best leverage it. We found it like the cleanest architecture that allows us to move fast and come up with with fast turnaround on like feature development. In LinkedIn.com, we do apply 3x3 continuous delivery pattern. 3x3 is like a LinkedIn concept. It means that our target is 3 production releases per day and maximum time from commit to production 3 hours. And 3 hours, because if you shrink that time and you create this self-imposed constraint of 3 hours, like you really have to figure out your testing strategy. Like you can't have end-to-end tests that take forever to execute and then they will fail anyway, right? You have to really figure out how we test and what we don't test, what we monitor to make it work. And that helped us a lot. Like it was super hard for us. It was 2015 where we introduced 3x3, and we've been pushing that. Like we had to tackle like the problems of flaky tests and slow builds and like slow tests. Like we massively parallelize our tests and tackle and really rigorously tackle complexities and flakiness. At the same time, it's a constant challenge. So it's not a rose garden. We are properly challenged to keep up with continuous delivery. And of course, those code bases would have independent release cycles. It's very important because this is also a way for the entire organization to move fast, to be productive, right? It's not like we're building this monolith from scratch, slow build, like you ship everything, but really small independent teams can operate really fast and ship to production frequently. What else? Huh? What's up? I have technical problems with presentation. There you go. Thank you. So let's look at testing in LinkedIn.com. And when I say LinkedIn.com, I mean flagship, like our main product. Keep in mind that LinkedIn is bigger. We have a bunch of other products. So tests are isolated. So we have unit tests, integration tests, and scenario tests, but they are all like isolated. Like we use mock results from like downstream calls. This is important. This allows us to have stable tests and move fast and like have that. We found it working for us, and it allowed us to implement continuous delivery. There are challenges there as well. Like for example, one is that some of our mock data is stale. Like it's old and should be changed, but like it's hard to change it. Like it should be simpler, but it's kind of hard. So people like find some workarounds. So it's again. Like when I look at our scale with thousands of changes per week from 300 unique contributors and then shipping it several times a day to production, I'm amazed with the scale. But keep in mind that there are challenges. It's not like super easy to do, and like we are properly challenged. What we exclude from pipeline, which might be surprising, is that we don't do like Selenium-like cross-browser tests like during the pipeline, because that's not going to work. Like that's going to be too slow, too unreliable. There will be so many false negatives that like we didn't find it like useful. We have capability to do that. We have the Selenium farm, but that's not what's in the pipeline. Like commit to production pipeline is automated, and there's no manual testing in that process. Right? There cannot be. Like if we need to ship from commit to production in 3 hours, you can't have like humans making decisions and like testing things. It's just not enough time to do that. We also don't include in our pipeline real mobile device testing, like with real mobile devices. We do have a device cloud, and we can do some of the things, and we are considering adding some performance tests that potentially we can hook up to the pipeline. But today we don't do it. Maybe in the future we'll see. It's not like. The risk there is, again, slow tests, unreliable, false negatives, and those are the problems that will kill like continuous delivery. Like you can't have flaky tests, you can't have unreliable builds and slow builds if you want to do continuous delivery. That's just, yeah. We also don't do end-to-end tests. They are too slow, like too complicated, like too unstable, because you have to, the system is so complicated, you have to set up so many moving parts that like it's hopeless. Like we don't do that. There's an interesting, unique challenge, like how to do Canary releases for mobile. Huh? Do you guys do Canary releases for mobile? No, because it's impossible, right? So with Canary, what you do is you install a new version of one host, and if something goes wrong, you take it back. Yeah. But in mobile, you cannot take it back, right? If you send an application to App Store, it's out there. People downloaded it. Like. People may not upgrade your app ever again. They might be happy with your app, and that app might be buggy. So this is an industry challenge. It's an industry problem, how to like deal with that for mobile. And there are ways of managing that risk. There are beta channels that are useful for us. We find a lot of value from that, where there is a main application and there's a beta application. The beta application is updated more frequently to the App Store, whereas the main application is updated every week. Like the 1 week release window for mobile application is like a golden golden window, right? Like you cannot do it more often because people will be pissed off. Like you're updating app all the time. You're eating my data. What's going on? And like doing it less frequently, let's say every 2 weeks, like imposes various risks with slower release cadence. And I cannot stress it more. Like for server side, it's easy to do releases every day or like multiple times a day, or for web, right? Because this is like we know how to do it. It's easy. You just ship new version to production and everybody's hitting new version. For mobile, it's hard. But what I want to say is that you really want to shrink down your release window so that they are as frequent as possible. Even with releases on every week basis, you can observe this pattern. Let's say you release every Wednesday. Every Wednesday you ship to production. I bet I'm gonna bet a lot. I can bet a lot of money that on Tuesday you have the most commits in your team. Like people are like, oh, release is tomorrow. I need to finish my change. Like unit test, maybe later, maybe on Thursday. My change needs to go out, right? So you have these tensions, right? And then like when those tensions exist, what's happening is that like lower quality code gets included. This follows a phase where you stabilize your release, right? So you don't want to have even weekly releases like daily releases, or like several times a day. This is where you want to be. Not for mobile though. For mobile, we have different challenges. Okay, let's look at how we do testing for our microservices. We evolved from monorepo, and I have some really interesting stats for you. About 6 years ago, we started to gradually move out from monorepo, and like new modern services, new code was developed outside. Last mile, so about 2 years ago, we finished, like at some point we were at the point where the monorepo had like 12 million lines of code, roughly, and there was almost no development. Like people were developing outside of it in like a separate code bases. At the same time, the monorepo kept you still had to maintain it, and with monorepo, we had all that layer of custom tools to make it work. So we decided, hey, let's get rid of it. So the last mile to get rid of the last 12 million lines of code, several engineers were working on it. It took 2 years. It's like a big thing. Like we at LinkedIn, we love those huge cleanup tasks, getting rid of tech debt, like a team of cowboys just work on this. This resulted in creation of 800 code bases, and the dependency graph there was 12 level deep. Like that's a proper dependency graph. And I think they killed about 4 million lines of code, and the rest was transitioned into a new tools that we have, new multi-product, new framework that we have for building products at LinkedIn outside of repo. But last summer, somebody did this svn delete that repository, svn delete. It was svn repository, by the way. Don't you love svn? It's awesome. Today we have 500 microservices. It's about 3.5 thousand REST resources in total. This does not include our API services, so it intends to give you a glimpse of the scale. And they have independent dev and release cadences, and this is the key for productivity for us. Like in monorepo, it's you get this coupled developer deployment cadence. Like you build everything from head. Like we don't like that. This is not productivity for us. We want nimble teams and going to production fast, and independent dev cycles, independent teams, the way to go. So for microservices, we use REST and RESTly framework, which is open source. It's Java. We use Play framework for most of the new microservices that we're building. At the same time, we don't quite use Scala. We use Java 8 for developing Play framework apps. Although Play originates from Scala, we don't use Scala. Some of the testing framework support that we have for microservices. So we have a framework for recording real production traffic. Record playback. It's very useful, very successful, easy to get started with. Challenges exist with this framework, with adoption rate for like we want to use it as a standard for all the projects. The test framework was developed after we had the infrastructure, so some teams still don't use it. So It's not completely there, but like it's very useful today. Like we use it in LinkedIn.com, for example. Also, we have another framework for mocking downstream calls. It's for slightly different use cases, but you can also write very good, robust tests for your microservices with that framework that we also have, and it's based on Mockito, which is nice. And we also have framework for dark canary testing that you can use with microservices at LinkedIn. What's the difference between canary and dark canary? So the canary can impact the production, right? Because the production traffic is hitting the canary. So if that canary is failing and sending exceptions, the user can be impacted, but hopefully your architecture is good and, you know, like the user is actually hitting a different hosts that actually work. So it may or may not. Long story short, the canary release potentially can impact the user a little bit. At the same time, canary release is very useful regardless, because it's better to impact small amount of users for a little bit than really allow like a big problem in production where like you impact everybody, right? Dark canary does not impact production because it's like you operate on a copy of a traffic, like a copy of a request. So it's useful. It's also a very, very useful strategy. Come on. Oh yeah, thank you. I also want to talk about search verticals at LinkedIn. So at LinkedIn, we have a framework for developing search. Like we don't want to reinvent the wheel, and if a team needs to do search, like we want to provide a framework for them. Search have this unique challenge when it comes to testing in production. Let me tell you a little bit about it. So it is a stateful service because there's this index file, this like data that you search in. And this file is big, it's really huge. Like to give you some example, for one shard, for one of our biggest search, like one shard of 64 shards can be tens of gigabytes, like one file, one shard. It's big. It makes, like how do you automate around that? Yeah. Another thing is, something that works, is that the member data, which means that that the index file, which has the member data, and also any search queries that we use, they are protected by law. Like if you know about GDPR, you know what I'm talking about. So we need to figure out how to test automatically, how to make it work. So what we do is in our CI step, we fork off, and we can run some testing in a DMZ zone in production. The reason we do it is that it's really hard to reliably test search without production data. Like search today is like complicated. Like it's a fuzzy search. It can give you like partial results and all that. And like testing search with some surrogate data or with some fake data will not give you the same signal, right? So we really want to test with the real production data, but it imposes certain like problems but there are ways to like tackle those problems as well. Finally, resilience engineering that you should be doing more and more, and I have like 2 minutes, so I'm not going to spend that much, unfortunately. It's another example of testing in production. It's fault injection. So distributed system is complicated. What you want to do is you want to experiment on that distributed system to identify problem. This is how you get from 3 nines to 4 nines, from 4 nines to 5 nines. If you are tracking your revenue based on your site up, right? Your site is up and you're getting revenue. Your site is down. You don't get revenue from ads. You know what I'm talking about, right? Like having production issues where something is not working is an impact on the revenue, and you should be tracking that. So resilience engineering like helps with that a lot, and it's becoming mainstream these days. So I'm very happy. There's one more thing that I really like about resilience engineering. So when you have an incident in production, something broke, let's say you fixed it, yeah? What happens next after you fixed it? What happens? What do you do? Come on. So you do postmortems. We always do that. But it's a waste of time. Why? Because you should have detected that problem earlier, right? There should not be a postmortem. We should be like practicing resilience engineering and figure out problems before they happen. I don't have anything against postmortems. We should be doing them, absolutely. But I would love to identify those problems earlier. And there is a great article from Charity Majors. If you read that article, you wouldn't have to come to these presentations. So that's why I show it at the last slide here. And key takeaways for you. So leverage the diversity of real users and real production environment, because this way you can find bugs that you cannot find in pre-production. That's from Seth Elliott. I like this pure statement. Only production is production. I'm out of time, but it's going to be just one. It's my last slide, I promise. It is hard to replicate a complex distributed system in a staging environment. And every system today is complex distributed system because we are in the microservices era. Also, failures in production will occur. So the question is not like, it's really if it impacts all the users or whether it impacts like a small portion of users for just a little bit of time. Because if you automatically roll back your Canary, then nobody's paged. A developer is not waked up and, hey, so there's a problem, you have to fix it. Things to do more, like fast and reliable, like isolated tests. Also Canary releases, A/B testing, resilience engineering, local dev testing with pushing the downstream calls to production. We find it very useful as well. Those are your key takeaways. And I don't have time for questions, which is good, because you would expose my ignorance and lack of knowledge. Thank you very much.